Welcome back. In this lecture, we're going to talk about how to visualize vector data and raster data using the MapLibre backend. Before we get into the details, I would like to show you something on Google Colab. So in the last lecture, we talked about how to create MapTiler API key. And in the noble example, I show you how to set this one as an environment variable. And so it's a little bit inconvenient on Google Colab because you have to specify every time. It's going to take some time because you need to log into the website to find the API key. If you're using Google Colab, you can actually, on the left side here, 1, 2, 3, this key icon, if you click this one, it allows you to set an environment variable so that we don't have to set it every time. What you can do is to go to your MapTiler website and then go to the API key. So if you want to use your default one, I can just simply just come here, copy this one, and then you can just create add new secret. So over here, you can just Control S, just paste this API key. And for the name, you need to use this one, MapTiler, all uppercase underscore key. So I'm going to drive this one and then paste here. And that's it. And then you can turn on this one. So if you don't, so let me show you what happened. If I'm going to go to the 3D mapping here, for example, the MapTiler, for example, this one here. So if you try to run this, right, it's going to automatically ask you, do you want to grant access to the secret name MapTiler key? You can just click grant access. Yes. And see, it works just out of the box. So this is the better way. So if you need to save the API key, I recommend you using this way. So when you are running the exercise, you don't have to keep going to the website, and also you avoid exposing your API key because you don't have to set it explicitly using this one. So you don't want to write your API key. If you are trying to submit the lab assignment, don't have the API key on your notebook, okay? It's just like your username and password to your account. So people can steal your API key to run it. So make sure that you set as an API key, you can run all the notebook, you can get all the result. But this is only recommended if you're doing it locally, using your own computer, using Jupyter Lab. If you're using Google Lab, set an API key, and it's so much easier. So this is something I want to show you before we get into the details about visualizing geospatial data. Again, don't expose the key. So I'm going to replace this one after I finish this lecture. And so previous lecture we have covered some of the base map layers and also the 3D. So starting from this, we're going to talk about visualizing vector data. So there are just two primary type of GIS data, vector data or raster data. So first we're going to take a look at some vector data. And vector data has point, line, and also polygon. And MapLibre is a lot more flexible and powerful, so you can use a lot of visualization options to visualize vector data. And vector data, if you you can create a simple marker. So a marker basically is just map.8 marker, and then you can provide the leg long. So the long leg, so X and Y. You can press Shift tab to, let me run this one just to show you, right? So you can specify the location, the map, the center, the zoom level, and also the location. So if you click here, it's going to undefine because we don't add any tooltips right now. So this is the simplest way to add a marker. Basically, just provide a longitude and a latitude. That's it. You can also provide a pop-up, like what kind of a pop-up you want to utilize. So if the data have some attribute you want to show up, you can do that in the pop-up. But right now, we can just add a simple marker. You can also add multiple markers. Oh, the second one is draggable. So do you want the marker to be draggable or not? By default, it's not draggable. So if you look at this one here, if you drag, it's basically just drag the base map. But if you provide this option draggable equal to true, then I can drag this one to a different location. So if this is something you want, you can do that. Next one, we can plot all the markers together. So this can be useful if we need to plot some points. So this is just a GeoJSON file, the world cities. We have utilized this one in the IPyLive data lecture. So for now, we're going to basically use the div map, the function read GeoJSON. Basically, you're going to read this one as a JSON dictionary, And after that, just call this function. So similar to what we have in the MapLibre backend. So create a map and then you set the style. Then you can use the add GeoJSON, just one line of code, add GeoJSON, and then give the GeoJSON dictionary and give the layer name. And the pop-up is like cities. So basically the pop-up is what kind of layer, which layers, because this layer name is called cities. So you want to add a pop-up to the layer name, the cities layer. And this one, heck look, it's super quick. And these are all the zoom labels. So you can see here by default the points. If you click this one, it's going to show you the pop-up. So this is where this one's coming from. And very much similar to what we have in the MapLibre, but it's a lot more flexible and also a lot more faster. MapLibre, when you have too many points, is actually pretty slow because everything is an widget. And so shift tab here, if you really want, you can customize. So the paint here allows you to specify what kind of color you want to specify different. So this is using the default, so you can change the color, you can change the size, change the radius. So it's really up to you what you want to utilize. So by default, I think there's also the type, the layer type. So it's going to basically figure out whether it's a point, a line, or polygon, and then it's going to use different default styles. And this overall, it looks fine, right? So all the points, if it is too big, you want to customize it, you can change the size. So what you want to do here is basically change the style. So let me show you. If you want, capture this one, paint. So the paint is going to allow you to look at the data layer. So I'm going to go to MapLibre, then go to the style spec. Then you can go to layers, right? So this would be just the circle. So the circle, and then you can, for example, a circle radius, right? What you want to change, and also the color by default. You can also look at the leaf map source code. So I can show you by default what kind of source code was utilized to create this one. So if you go to the API reference and then go to the MapLibre, then go to add GeoJSON. So this is basically the function, the map at GeoJSON source code. If you go below here, click this one, it's going to show you all the source code. So clearly, for example, here for the features, you're going to get the type. So if it is a point or multi-point type, this is going to be the paint. So basically the default one. So if you want to customize it, I can come here, I can just copy this section. And then I can come to here, the source code. So paint equal to this one. Then again, paint equal to paint, right? It will still be the same. Oops. Oh, then you need to specify the types. So right now, this would be, because you provide the paint, then it doesn't know exactly what you want to use. So you need to basically have the layer type equal to double quotes, and then it will be circle. Then it should work. Okay, so it's still the same point, and this is where you can customize. For example, the circle, the radius is too much, I can change it to 3. I can change the circle color, and the stroke color basically is the outline. So the outline is just the red color, the white color. So inside this is just the blue color. So I can change it to something else. For example, I can change it to red. And if you run it again, so now you have the red points, red dots, right? So it's super flexible, and you can see it's really fast. It's much faster than MapLibre. And if you click your mouse on the point, then it should show up all of this. If you don't want to use the pop-up, you can uncomment this one. Now it will be just the points. So if you click on the map, oops, interesting. Basically means by default. Or maybe when you have multiple data layers, it may not have that one enabled. So you might need to use the add pop-up explicitly for a certain layer. So this is how you can add point, GeoJSON file representing points onto the map easily. Besides that, you can customize the icon. So this is the same data, but right now we're using a custom symbol. So in order to do that, you need to add a data source. For example, the source is the same GeoJSON data, but we're going to build a layer. So the layer right now, the type is called symbol, because earlier we used the circle, right? So MapLibre has different layer types in here: the fill, the circle, the heat, free extrusion line, symbol. So the symbol actually means that you can customize it to a different symbol. So it can be text, it can be images, it can be all kind of stuff. So this one has a lot of parameters that you can customize. It's very flexible and it's very powerful. So what we're trying to do here is that we're going to, because this is the source is coming from this one here, the source, basically the point, the name is the point source, and then you can have a layout. So we're going to use the icon image, and then we're going to use the marker 15, the icon size, and this is what it turns out. So that means for all the point data you see here, when you zoom out, it's going to basically don't show all of them. When we zoom in, it will add more points. So this is basically rendering the points on the fly. So it's really cool. Again, when you click on the map, you should be able to see all the attributes, right? So you can either use the add GeoJSON function, or you can use the add the data source. So get pointing to the source. The source is a dictionary, and then this is the name of the source. Then the layer is built on top of the source. So make sure this name is the same as this one. Then you can specify what kind of types. It can be a point, it can be anything else. You can icon size. So again, it should be coming from this here, icon size, icon image, right? You can also rotate, icon rotate. So for example, for this one, you want to rotate. By default, it looks like this, but we can certainly try it out. Icon rotate, and we can rotate it maybe 45 degree. Let's see if it works. Yeah, you see how flexible it is. It's really cool. You can also customize the icon image. So right now we're just using this default one. Some of these actually are available through the MapLibre package, but you can provide a custom icon. So if there's only for any points that you want to use an image that you want to provide, you can do that as well. So what you need to do here is to find out the URL to a certain image. For example, this is the PNG, a logo, open geospatial logo. Then you can use this add image, and this should be the name of the image, and this should be the data source. So the custom marker, then you can use this one in the data source. So again, this will be the GeoJSON, and then we're gonna add the data source. So here will be the layer built on top of data source. And for this one, for the icon image right now, right? It's going to use this one because when you add the image, this will be the basically the name refer to this particular one. Then you can have the text field, basically the data, the GeoJSON have the year column, and it's going to basically get the year based on that one. And you're going to use different font, text, anchor, something like that. So this one, see what happens, right? So pretty cool. So this will be just a different year when the conference was held at different locations. So you can specify the logo. You can also specify the year, and the text label will show up. So basically the get year, the text field is coming from the data itself with a custom icon and a different size and also offset. And this is how you can customize the color. So the logo can be anything. You can change the logo to whatever something you like. For example, I can maybe let me see if I can find Google logo. But it need to be a direct URL. So if it is not a direct URL, it may not work. So let me copy this one and then come here. Let's see if it works. For example, this will be the one, the thumbnail. So we click this one. This is just SVG. I'm not sure if XVG works or not. So copy this one, and then we can try here, image. It may or may not work. I have not tried this one, I'm not quite sure. All right, so SVG doesn't work, so you need PNG actually. So because it's custom image, and I'm not quite sure. PNG logo. Logo PNG. Okay, let's try it. download PNG. Yeah, we just need a logo through a direct URL. Anyway, this doesn't work. You may need to download this one to computer, but I think you will need a logo that's accessible through HTTP URL. Okay, so this is how you customize the logo. So using the point data. So for the markers, you can just use the add marker, or you can use add GeoJSON. Then you should load all the data. Similarly, you can use the line data. So again, this is just a data source. It's a GeoJSON, and this will be just the line. Then we're going to add the layer. So again, this is the route source. And going to be the same name here. And we're going to render this one as a line. And then you can have the layout, you can have the pane. All this together, so let's see what it looks like. And this is just a single line rendering a GeoJSON file, a GeoJSON dictionary data source. And the pane, for example, the color here, we have 3 digits, but you can change it to whatever you want. For example, I can change it to yellow, so it'll be FF00. And the line width, I can change it to maybe a narrower one. All right, so right now it's yellow color, line width 5. Again, for all the line, all the parameters here, it comes from this here. So again, the line, and then the line width, line color, opacity, visibility, line join, blah blah. So it's up to you. You can customize to whatever way you want. This sort of should be a line pattern, line type. I guess there will be some solid around it. Line pattern. No, this one. Line blur, line disarray, line gap width. Yeah, there are basically there are a lot of options you can explore to some of these options. Some may or may not work. I'm not 100% sure. So this is for line data, and the other one is polygon. So polygon data, you can also provide a dictionary. Again, add that as a source. And so this is, for example, the marine, and then you can have the layer, and the layer, this is for polygon. Usually you want to use fill the polygon, and then you have the color, opacity. So this is what it looks like here. Right, so this is just a simple polygon being rendered using this particular color. So if it's just 3 digits, or you can have a 6 digit hex color code. So again, I can change it, for example, to 0000FF. Then it'll be just blue color, 80% transparent. Right, so it's up to you how you want to do it. The easiest way will be just add GeoJSON, so that you don't have to deal with all the add the data source and then add the data layer. So the add GeoJSON function is a lot more easier. So just create a map, and then how you want to render the polygon, just use the add GeoJSON and get the layer type and also the pane, then it should be it. So try to use this one. Unless something doesn't work, then you can go back to the original one, add the data source, add the data layer, and then specify the visualization options. And so the next example I'll show you actually is like rendering the buildings. So we have utilized this one actually in the previously in the lab exercise. For example, the leaf map exercise. So if you go to this one, for example, previously we render the buildings, for example, here, like something like this. So you can have a raster imagery, and then you can render something like this. We can do something very similar using MapLibre, but it's a lot more powerful because you can have a fill the color. You can also have an outline. So what we're doing here is just providing the URL to the GeoJSON file, and then specify how you want to visualize that. You can have the fill color, fill opacity, also the outline color, so it can be different. So this one here, you'll be inside, it's using the yellow color, and the outline we're using the red color. Then just use this one, add GeoJSON, and then with the field type, the pane, and also the layer name. So this is what it looks like. And the only downside is that the outline, the width is always going to be 1, so you cannot actually change it, because this fill option here, you only have a fill outline color. You don't have a fill outline width or something like that. So you cannot change it. The alternative, you'll be using this way. So you can have a GeoJSON and then you have a pane. You can add a GeoJSON. So you can add basically two data layers. This basically edit twice. The first time you use the polygon, the second time you use the fields, right? Fill and line. So this one you can find control. So if this is something you want, sometimes you want to customize the line width and also the center. Right now you see right now the red color is a lot more thicker because if you're just using the fill, then you cannot change it. So basically it's the same data, we edit twice and all using the add GeoJSON function, but the layer type has been changed. So the first time we're using the line, basically just the outline, and then the second time we use the fill, fill with yellow color, and then without the line width, and this is what it looks like. So certainly, if this is something you want, use this example, for example, fill. Otherwise, just the outline. So the outline is just red color, and the fill would be yellow color. So we have two data layers actually in here using the same GeoJSON data source. Okay, so this is line and polygon. So you can actually have multiple geometries together in the same GeoJSON file. So again, if this is the same GeoJSON file, we're gonna add that one twice, very much similar. And the difference is right now we're going to use the fill extrusion, right? So compared to earlier using the line and also the fill, right now we're using the line and also the fill extrusion. And the fill extrusion means we're going to get the property based on this value, and we're going to basically extrude the height based on the square. So this is basically the housing price in this Vancouver building blocks data. Let me run this one, let's see the results. It's really interesting. So now we have these 3D buildings in Vancouver, and the height represent the square, the value per square meter. So that means these are really high values. That means are very expensive buildings. And so the yellow color means it's cheaper. So these are certainly something very interesting. It's very nice for doing visualization. And again, it's just as from a GeoJSON file. We are going to render using the line, and the other one render using fill extrusion. And you can add all the properties here. One thing I want to introduce here is called this one called layer interact. So this one allows you to change the data layer interactively. So I'm going to basically, you can turn the layer on or off. So this is using the line representation. And this one is using the block fill, right? So the block line, block fill color. You can also change the opacity. So super cool, super responsive. And similarly, you can turn this one off. If I change this one, if I turn it off, now it's not there anymore. I can turn it on back on. So you can utilize this example. So if your data have some values, you want to use that value to extrude the polygon, then you might want to use this way. So again, all you need is just a GeoJSON file, or it can be a geodata frame, or it can be any vector data that GeoPanda support. And you can just get the GeoJSON, basically the geodata frame to JSON. Then we get the JSON dictionary. Then you can just pass into this add GeoJSON function, specify the layer type. By default, it's going to figure that out automatically, but you can specifically ask like what layer type you want to render. So although it's a polygon layer, you can also render using a line. So basically just the outline. We can use the fill, or you can use the fill extrusion. So basically, depending on your requirement, you can change the visualization. Okay, so this is about multiple geometries. The next example using marker cluster. So we also have the same similar example that we covered before. I think it's somewhere here. For example, marker cluster. We can do the same thing using MapLibre. Although the source code here looks a little bit more complicated because we have this GeoJSON file representing earthquakes, and then you need to add the data source, basically, the source arguments. And source argument is when you add GeoJSON, right? So you're going to have the circle, different circle and different color. And this one certainly is a little bit more complicated, the source code, but you can follow the example, somewhere here. So each circle represents how many earthquake points. So if we zoom in, the marker going to become smaller, so we're going to speed it up, split into a smaller one. But if we zoom out, it's going to cluster them all together. So this all represent the number of earthquake points, and it's actually a GeoJSON, right? So again, it's the same data set right here, but it's using different colors. So it has the point count, the filter, how many points, and the marker cluster, also the label. So the last one here is just a symbol. The symbol represents the number putting on the circle, right? The circle also have different color, and so if you ever need to create some this marker cluster, you can follow this example. Again, the source code is a little bit lengthy. I'm not going to get into details about this. You can take a look at this. It's very much similar. So all the GeoSense file, you're going to have the name and the filter and also the paint. So the filter means basically just get all the data that has this specific property. For example, it has the point count properties. Then you're going to extract the points. Sometimes you might have a point that doesn't have that column. It's not going to meet the requirement. So you can filter the data on the fly to bring to the map. So this is about marker cluster. And next example, local vector data. This one is duplicate, so I probably need to remove one of them. Okay, I didn't realize that, so let me remove this one. So local vector data means if you have some data locally, you don't know how to add it, you can just download. For example, we download this sample vector data set, and then we can just create a map. So this is just the simple default base map. Then you can call this open GeoJSON function. So if you run this one, it's going to use the iPad widget, and this one allows you to open something on your computer. So you're going to pop up showing you the file browser dialog, and then after you can just come here, zoom to this one, the data, for example, the US state, right? So we just downloaded this one and then just open it. It automatically load the data. So this is just an easy way for you to load any GeoJSON data if you want to, but you can always use source code. So you can just point into add the GeoJSON, and then without having to do that manually. So let me show you. I can just this URL and then just m.add GeoJSON and then just point into the URL, and that's it. I don't think you need to. Yeah, so you can either do it programmatically, or you can use this one app.open JSON. Sometimes if you don't know where the file is located on your computer, you want to use the file browser to find it, then this can be useful. So this is how you can add a local GeoJSON function. And another thing that I really like about MapLibre is that it's very flexible and powerful for doing visualizations. You can customize the properties easily. So for this particular example, we are going to basically change the building color. So the building comes from the base map, and we're going to use the set pane property. So this is basically the unique ID of that layer, and the fill color we're going to interpolate, right? And this looks complicated from zoom level 15 to 12, and these are two colors. So when we are zooming in from 15 to 22, it's going to interpolate between these two colors, and they're going to be used basically interpolate exponential. So you can have fill color, fill opacity. You're going to do this. So let me show you what it looks like. So when you render this one, and now you see all the data layers. So this is basically from the basic MapTiler base map, and all the layer here right now, actually there are lots of data layers, so it's actually too much. So I need to click this one to see the full screen, and the buildings, right? So if you zoom in, you can see the color. It actually changes. The more I'm zooming, you can see the color actually changes again. So this basically allows you to customize. If you want, you should be able to see the building. Let me see here, building, basically this one. So you can turn the layer on and off. You can turn the background. You can turn all the data layer. So everything here on the basement, because it's a vector tile, so you can turn the layer on or to anything you like. So this is really powerful. For most of the MapLibre, the data layer, when you put it in, it's already fixed. You cannot actually turn layer on off. But this is different. So this is why the vector tile is so powerful, because you can customize the visualization to the way to your liking. And you can change data layer, you can change the color. So again, right now, this is just changing from this. We can just do it in here. For example, I can change it from red to green, right? So I can change it to FF000 and maybe 00FF00. Let's see what happened. So right now it's zoom level, I'm not sure how much, but when zooming, you should start to see red buildings. Oh no, no, this one is the fill color, fill opacity, or exponential. So this is not linear. So I can change it maybe to where's the linear? Let me see. It's a little bit complicated, so sometimes you do need to. Let me go to the 3D buildings. I think I have an example here called interpret linear. And so let me go back to where is it? Local vector, change building color. So this one I can change it to linear. LINEAR, and this one doesn't have this parameter. And see if it works. Oh, there's an E here. I'm sorry. That's why it doesn't work. Otherwise, it would work now. So red to green, right? You see the red color, and then change it all the way to green, right? So this is how you can customize the data layer easy on the fly. So very, very powerful. And you can use this function called echo. So this is basically calling the function available in the JavaScript library. So echo function is also a very powerful one, because you can call any JavaScript functions that has not been implemented in the MapLibre Python package. So for this one, we're going to zoom to zoom level 19, and then the duration is going to be 9,000 milliseconds. So let's see what happens. Run this one. So you're going to zoom in automatically. You should see the color changes depending on how we want. So maybe you want to change to 22 so that it's oh, because we already zoomed in, so that's why maybe I need to run again, and then zoom 22. Right, so from red to green, interpreted. Super cool, and it's very, very smooth. Try it out. Add a new layer below the labels. I think we have covered this one before. Basically, when you add the data layer, there's a before ID parameters. So ID parameters, you can specify if you already know the name. If not, you can always like find first symbol layer. So this one is going to use basically the base map, and then you're going to find the first symbol layer. So whatever data layer you put is going to be beneath the layer, the symbol layer. So here we add the polygon, and if you see the polygon actually beneath the symbol. If you don't do that, like this, the polygon will block the label, so you won't be see the label. So the label right now, it still shows up. The reason because I will put the transparency here to 0.4. You put the transparency to 1, then it will block all the labels. For example, change to 1, and now you won't be able to see the labels. It's all blocked, right? So this is not very good because you don't know where's the location. So you certainly want to change the, not just the transparency, you also want to have the before ID equal to, and you don't really care where's the first symbol ID. You don't need to know that. You can just here ID, and then it should be it. All right, so now you have the label on top of the data layer. If you really want to find out what it is, what this one, the symbol ID, you can just run it. So it's a water name line. So basically all the symbols is going to be put on top of the other data layers. And you can actually add a layer control. So let me show you here, add layer control. by default, the background data is not added. So if you turn like BG layer equal to 2, then you will out all the data layers. And the first symbol one is actually this one. But right now it's because it's a vector type, so there are a lot. It doesn't show them all in here, so we cannot see which one. But the name is coming from here, water name line. So basically, there's a layer, symbol layer, that water name line. Let's see here. Water, yeah, we don't see in here. This might have sometimes have hundreds data layers, so it's maybe a lot. But you can just use the find first symbol layer, and then because every layer has this ID attribute, so you don't really care about which one. You just let the program figure it out themselves. So this is about 18 layer beneath that. And the next one is about heat maps. Again, this one is similar to the marker cluster examples. It's actually quite complicated. It's using the same earthquake data. So it's the same earthquake data, but right now we're using the heat map. So when you zoom in, you can see the cluster, and when you zoom out, it's going to be a point. So I'm going to show you basically the heat map is basically showing you the cluster, basically where those earthquake happening. And if you click zoom out, it's going to show you the color. So if you need to create some like density, find out the hot spot, cold spot, this can be helpful, right? So you have different data layer here. Again, this is a little bit more complicated, just as an example. So in the future, if you need it, you can try to follow the same example in here. So this is called ID, the data source, basically just the same earthquake, and then the layer type is the heat maps. And you should be able to find from here the circle heat maps, like radius, height, intensity, color. So everything can be customized using some of the things in here. Weight, intensity, color, radius, opacity, right? So all come from here. You do sometimes need to refer to the documentation to learn more about what it is. And in general, if you have run into any issues, you can also use the help documentation, or you can ask ChatGPT to provide some of the examples. And most of the examples can be provided using JavaScript code, but you can just easily convert them to Python. And the last vector example is about visualizing population density. Again, so we're using the GeoJSON file, we add the source, and then we add the data layer based on the source. And so we're going to use the fill and the paint, basically the color. And so this can have very complicated equations. For example, the density give a color, and they decide based on the attribute. They can interpret, and this is kind of nested one. Nested structure of the interpolation. So it gets quite complicated and sometimes can be quite confusing, but this one basically shows you if you have a polygon, you want to create, fill the color depends on the attribute, depends on the value coming from there. Sometimes you can even do some calculation on the fly and then to render color. So let me population density in the center here. Darker color means higher density. Lighter color means lower density. So this can be also be useful for visualizing vector data. Depends on the values in the inside the attribute table. And so we have covered a variety of vector data format, from point, markers, line, polygon, multiple geometry, and also some more advanced examples. So you do need to know about just those simple GeoJSON, how to render a point, a line, a polygon, and more advanced one. If you need to, for example, create population density heat map, you can also follow the examples in here. Next, we're going to talk about raster data visualization. So raster data, we also cover a lot in the leaf map example. So it's very much similar in here, visualizing raster. So MapLibre can do the same thing. So we can visualize satellite data, aerial imagery, single band, multi-band, cloud optimized geotiff. So we can do very much similar. And in this example, first we're going to talk about local raster dataset. So You can download this sample dataset, for example, the Landsat to my computer, and then you can just use the add raster function. So the add raster is similar to the add raster in MapLibre. So you can just point to a file path. The indices means like which band indices you want to utilize, the minimum, the maximum, and then give a name. So we are adding this same raster dataset, but we're using different band combination. RGB, basically red, green, blue, and also near infrared. Then we add a layer control. So let's take a look. So this is just a simple Landsat data. And so we have two data layers here. This will be the first color composite 432, and this will be 321. So two data layers, and it's the raster imagery. So you can zoom in, you can see this is no vector type. So this is just a simple raster imagery. So when you zoom in, it should load up, increase the resolution. So when you zoom out, it's going to use coarse resolution. Also, similarly, you can use the layer interact. So the layer interact allows you to change the visibility and also the opacity, right? So this is 432. I can use this one to turn it on and off. I can change the opacity, something like this. It's super smooth. So this one is using like multi-spectral data. So two, the same imagery, but it's different band combination. You can also visualize single band. So we're going to download just a DM here, SRTM. Then we can use the add raster function. So for single band, usually you want to provide a color map. So for this one, it's a DM. So we can provide a color map, for example, terrain. And you see, super nice. And similarly, you can change the opacity in here, just like this. You can change video like on or off. So the layer interact function is kind of an interactive way for you to change the opacity, because we don't have that one just like a leaf map that allows you to change the opacity using the slider on the map, because right now it's difficult to integrate this one because the MapLibre package is built on top of any widget and also built on top of TypeScript. So it's a little bit challenging to add those things to the map right now. Hopefully in the future will be easier. And so this is the local raster dataset, but you can also use cloud optimized GeoTIFF. We have covered this one in the previous lecture in LeafMap. So cloud optimized GeoTIFF basically is just a regular GeoTIFF, but internally they have some overview or the pyramids. So allow you to do HTTP range request. So you can request image tiles on the fly. Similarly, we're going to use this example. We're going to use the Maxar open data imagery of Libya floods in 2023. So we have this one before the event. This is after. And what we can do is use the add cog layer, add cloud optimized GeoTIFF layer, and then add cog layer before and after, then add the layer control. So let me show you what it is. It'd be nice to have a split map, but right now MapLibre doesn't have that split map available yet. So it's going to take some time, but at least right now we can use this add cog layer, and then you can overlay the two data layer together, right? So this is basically just the Maxar open data and the high resolution imagery. So you can see we have the two data layer here. This is after, this is before. So you can certainly see the changes in here. And if you want to change the opacity to compare data layer, then you can use the layer interact. And you can do the same thing here, turn layer on and off. I can also change the opacity. Right. Although it's not as nice as the split map, but this is what we can utilize right now. So we can just use MapLibre to add any raster data, either locally or it can be the data in the cloud. Okay, so this is about adding cloud optimized GeoTIFF. The last one is spatial temporal asset catalog. Similarly, in LeafMap, we already covered it in the previous lecture about how to add STAC catalog and the same function. So this is the nice thing about using LeafMap, because you can use the same source code, and these are all the same. The same source code. All you need is just import LeafMap.mat libre GL, and then other things remain the same. So we can also change the the style, but these are pretty much similar. So we use the stack layer. What you need to do is provide a URL to the stack catalog item, and then which pane you want to use, and give a layer name, specify the minimum, the maximum, and we have two data layer, RGB, panchromatic, and you can zoom in, you can see the details. So it can be used to visualize any stack items from the internet. So as long as you have the data set, this is something that can be done easily. Again, we can also enable the layer interact, so allow you to interact with the map. So zoom in, slider, opacity, like this. Last example is visualizing data from Microsoft Planetary Computer. If you have never heard about it, this is basically a cloud computing platform. It used to be, they provide Jupyter Lab, but it has gone away, but still the data catalog is available here. It has lots of satellite data, some land use, land cover, different type data, and this is freely accessible. So you can also render the data directly from Planetary Computer. But what you need to do is like a collection, right? So for example, here we're going to use, let me show you here. You can show lane set, right? Lane set collection 2, level 1, level 2. So for this one, we're going to basically lane set collection 2, level 2. It's the data set from somewhere from here. And so inside, this is the stack catalog. You can retrieve the data, you can filter the data, and this one is continues to be updated. So what we're going to use is, okay, we're going to get the data from this collection, and we know the specific item we want to visualize. So this one from the unique ID for this stack item, then we can run it, and we can use the, for example, the t-tiler to render this data. And for this particular item, we know these are the bands available in this particular image. So it's coming from this collection, and this is the item ID, and this is getting access to the particular data. Then we can just use this stack layer. Instead of providing the URL, right now we are providing the collection and also the item parameters. And behind it's going to know, like, okay, if you provide these two parameters, we are going to use a Microsoft Planetary Computer for these two. And so the assets basically means the band, right? So when you use the B5, 4, and 3 to do the visualization and then give a name. So this one, and see how it works. Okay, so this will be a lane set imagery. So you can see it's loading up 5, 4, 3, basically force color composite, right? So you can read the data list from here. Where is it? Overview, layer 2, spectral bands. Oh, interesting. It's not layer scientific products. Is it this one or something else? Oh, here. Okay, 5, 4, 3. So you'll be sort with. Is it this one? Collection 1. Oh, it's here, right? B5, 4, and 3. 4, 5. 5 is red. I'm a little bit confused. SRB5, so not this one. I guess something has changed. There, yeah, should be this one. SR is not here. Maybe the metadata is a little bit confusing. Sort with. I don't see the SR. Surface reflectance. Anyway, I'll look into that later. But so this is how you can change the color. For example, you can suddenly change this one to be 432. Then it's going to be just a natural color composite. So let's see if it works. Yeah, so this is natural color, just RGB, so it looks like natural color. And again, this is just a simple way of rendering data from the Microsoft Planetary Computer using MapLibre. If you can find any other dataset, you can also render it using this way. As long as you know which collection you want to use, which exact item you want to visualize, then you can just use this add stack layer function to either render data from printer to computer using collection and item, or you can just pass in the URL if you know the URL directly to the dataset. Okay, so this is what I want to cover in this lecture. So we probably need another lecture to finishing up the MapLibre package. So I will see you in the next one.